Okay, here are two new situations where you want to find the new, but what you have is both a current and then one previous to the current. So there are three amounts that you have to contend with. So I'll show you. I'm just going to call it new, current, previous, or maybe past. I'll use previous, not past. So we want to find the new, whatever it is, whether it's population or whatever. Here's the formula. So it's the current. To get our rate, it's the current amount divided by the previous or the past amount. And then you're going to raise it to the desired time over the previous time. So if you have it like that, it makes it fairly easy. So what will the population be? So that's new. If the population was, so that is the previous, and the current, so this is the current, so the current population is 191.1 in millions. And then this ratio will be the 191.1 million divided by the previous population, 141.5 million. And we're raising that to the, let's see, if the population was 10 minutes ago, so this was the previous time that they were talking about. And we want to know what the population will be, so this is the desired time. This is the previous time. So the new population will be, and if you want to type in 190,100,000, you could. That's what I'm going to do. So there's 5 zeros at the end. And then parentheses. I better type it in that way because I don't want to have to type in all those zeros. So I'll type 191.1 parentheses 191.1 divide 141.5 parentheses, the caret button. We're raising that to 5 divided by 10. If you put 0.5, that's fine as well. So the new population in E. coli bacteria will be 222.08. Here. Or it will look like this. So 222,081,719.1. But what they're mostly going to be focused on is this, and maybe to the 80,000s, to the hundredth place. Okay, we're going to do the same thing here. You have a future is equal to current, or I guess I said new. And then you get your rate, the current divide the previous. And you're raising that to the desired time. I'll put D for desired time, over the previous time. Okay, so radioactive isotope curium-246 decays exponentially. So we're talking about a new mass. We want to know, what will the mass be 8,000 years from now? Okay, the new mass in 8,000 years. Will be means the equal sign. If the mass was, that's the previous. Current mass, so here's our current mass, 769.5 or 0.50 grams, and then we're going to put that again here because this is the current mass, divided by the previous, 2,968.29. We're raising that. 8,000 is the desired amount, 8,000 years. And the previous time they gave us is 9,000 years. So I guess I'm not going to put 1,000 in there. And then you just type in the calculator just like that. So 769.5 or 0.50 parentheses, 769.5 divided by 2,968.29. I pause because I try to always remember to check what I'm actually typing into the calculator. So it looks like the new mass of 231 point, and they gave it to the hundredths place, so I'll give it to the hundredths place, ounces in 8,000 years. All right, so that's when you have three different amounts that you're contending with. That's one way to think about it. There are other ways to think about it. So if the way I'm explaining it doesn't make sense to you, or there are a lot of people on YouTube, someone might be explaining it differently in a way that you can understand. So, but here's one way to look at it.